Hi guys, I am Mushako and I am back again with Maths XYZ, and today I will be taking you through trigonometric identities. With identities, we have two identities, of which the first one is sine squared theta, sine squared theta plus cos squared theta is equals to 1. From this identity, you can actually say sine squared theta is 1 minus cos squared theta. 1 minus cos squared theta. The same happens with cos. You can say that you can manipulate the equation to be 1 minus sine squared theta. This is the first identity. The second identity, which is for tan, it says tan theta is equals to sine theta divided by cos theta. And from this one, if 1 divided by tan theta, then that will mean that the answer for this one, it will be cos theta divided by sine theta. It's when you have an inverse of the first identity, of the second identity. Then how do they know that sine squared theta plus cos squared theta is equals to 1? And how do they know that tan theta is equals to sine theta divided by cos theta? Then let me show you how the proof comes from. If we have a triangle, right angle triangle, PQR, and this side we know that is the opposite. If theta is here, then this side is the opposite of theta, it's y, and this one is the adjacent of theta, and this one is the hypotenuse of theta. Remember, sine theta is equals to opposite over the hypotenuse, of which it's y over r, then squared. The identity says sine squared theta plus cos squared theta is equals to 1. Then let's see how, if from this Cartesian plane we can find sine squared theta plus cos squared theta is equals to 1. Then plus cos squared theta, cos theta is equals to adjacent over the hypotenuse, of which is x over r, and then squared. Then from here we have y squared divided by r squared plus x squared divided by r squared. Then now we take the lowest common denominator, which is r squared, and is equals to y squared plus x squared. Now remember, according to the theorem of Pythagoras, r squared is equals to x squared plus y squared, of which is the numerator. Y squared plus x squared is actually equals to r squared. Then we have r squared divided by r squared, which gives us 1. Then this just proves that indeed sine squared theta plus cos squared theta is equals to 1. Then for the second identity, which says tan theta, it's equals to sine theta divided by cos theta. Alright, let's look at tan theta. Tan theta from this Cartesian, from this triangle, is equals to the opposite over the adjacent, which is y divided by x. That's for tan theta. But then let's prove if it's equals to sine theta divided by cos theta. Sine theta from this one is equals to opposite, which is y, divided by the hypotenuse, which is r. And then cos theta is equals to the adjacent over the hypotenuse, which is x over r as well. Then from here we have y over r multiplied by r divided by x. These two will cancel out and we'll be left with y, y, which is the opposite, divided by x, which is the adjacent. Then it just prove that indeed tan theta, it is equals to sine theta divided by cos theta. Alright, let's do examples on identities and see if we can be able to solve them out. Alright, the first identity is sine squared theta plus cos squared theta is equals to 1. And the second one is tan theta is equals to sine theta divided by cos theta. Alright, the question says that we must simplify the following question, which is tan theta plus cos theta divided by 1 plus sine theta. Sine theta, we must simplify tan theta plus cos theta divided by 1 plus cos theta into as a single trigonometric ratio. That means that our answer should have only cos only tan or only sine. Then from here we know that tan theta is equals to sine theta divided by cos theta. Alright, we're starting to simplify now. Then sine theta divided by cos theta. That is for tan. Then plus cos theta divided by 1 plus sine theta. Alright, from here then we work out on fractions, of which this will multiply with that, this will multiply with that. Then we'll have sine theta into 1 plus sine theta as well. Sorry, just to have it clear, sine theta again, plus cos theta multiplied by cos theta, which will give us cos squared theta. All divided by, okay, let me just use another marker. All divided by, sorry guys. Alright, it's not working. Okay, then we'll just have to work out on this one. Alright, all divided by cos theta multiplied by 1 plus sine theta. Alright, then from here we multiply, out of which we'll have sine theta plus sine squared theta plus cos squared theta, all divided by cos squared, that this will be cos theta plus cos theta sine theta. Alright, now let's go back to identities again. Sine squared theta plus cos squared theta. From this, the first identity, that means that it's equals to 1. That means in the numerator we have sine theta plus 1, because this one, this whole part here, this in here, it's equals to 1. This is equals to 1. That means that our numerator we have sine theta plus 1. Then when we come to our denominator, we have cos theta plus cos theta sine theta, of which we can actually take the common factor, which is cos theta, and we will be left with 1 plus sine theta. Yes. Alright, let me just make space here. We'll write it here, taking it from here to the top. Okay, then we have sine theta in the numerator plus 1 divided by taking the common factor of cos theta into 1 plus, we'll have sine theta, 1 plus sine theta. That means that we have sine theta plus 1 divided by 1 plus sine theta, of which thus we can actually write it as sine theta plus 1, and they will divide out. The numerator and the denominator will divide, and we'll be left with only 1 divided by cos theta. Alright, that means that we've got our answer in the as a 1 trig ratio. Alright, okay, then let's do the second example. I hope you guys understood this example. Alright, second example. Okay, it says express sine theta divided by tan theta as a single trigonometric ratio. From this one, the first step that you must do is to change tan theta in terms of the identities, which will be sine theta divided by cos theta. And then from here we will divide sine theta divided by 1 multiplied by cos theta divided by sine theta, of which this and this will cancel out and we'll be left with cos theta. Then we have answered it in a single trigonometric ratio. Alright, let's do the last one, and for the identities. Alright, the last one, it says determine the value of sine theta plus cos theta squared, all squared, minus 2 sine theta cos theta. Alright, from this one here we have multiplying in, it will be sine squared theta, value of sine theta plus cos theta all squared minus 2 sine theta cos theta. Alright, that's cos theta, the last one thing. Then multiplying out here, it will be sine squared theta plus 2 sine theta cos theta plus cos squared theta minus space this, the minus for this one, it will be minus 2 theta cos theta. Alright, from from here we can see that this positive 2 sine theta and minus 2 sine theta will subtract each other and it will be 0. Then we'll only be left with sine squared theta plus cos squared theta. And from sine squared theta plus cos squared theta, we know that this is an identity which is equals to 1. Alright? Always remember that with identities, you always just manipulate the equation around. Just know that sine squared theta plus cos squared theta is equals to 1, and the same thing happens if you want to have the value of sine squared theta. That means that sine squared theta is equals to 1 minus cos squared theta. The same applies for cos. It will be cos squared theta is equals to 1 minus sine squared theta. And then for tan is equals to sine theta divided by cos theta, and as well 1 over tan theta is equals to cos theta divided by sine theta. And then when you are answering a question, you just manipulate the equation around, change where you can change. If it's tan theta, change it into sine theta divided by cos theta. If it's 1, you can change it into sine squared theta plus cos squared theta, depending on how the question looks like. And then you can work it out around and see if you can simplify it into a simple equation. Alright guys, I hope you enjoyed today's lesson. Don't forget to subscribe to Maths XYZ so that you can get daily notification when we upload videos. Thank you.